What's up, gamers? Well, we're gonna do some robotic welding tutorials here, getting ready to work on pin 1 for 15-inch arms. It's our 15-inch arms. We got 500 times 2. These are our pins. It's our teach pennant. I have a universal program set here. I'm gonna go ahead and just demonstrate that. Sorry about the gloved hands, and sorry about the weirdness with the camera. I'm not used to doing this. So this is our station set. Put it in teach mode, and then we have to flip that into teach mode as well. All right, let's check our stations. Let's take a look at the program. So focus. Most of these programs I made myself. A lot of them are pretty old, but we're going to be using this one right here. It says Uni Program, Uni Pin Working, which means Universal Working Pin Program. And the reason for that is, and the reason why we have all those other different programs, we have a new jig here that Robert designed. It's a reinforced jig, so the parts sit a little bit better. And I'm going to demonstrate the welding capacity for that, and how a universal program can work for that, as opposed to having individual programs. You see all those other individual programs? That was for the old previous jig configuration. So we're going to do some test welds. This is actually the first time with this new jig configuration that I'm doing pin 1s. So we're going to take a look and see. I've done 3 and I've done 2. Haven't done 4 yet. But yeah, we're going to see how that works out. Alright, just for clarification, these are how some of this is a pin 2 order. Pin 2 left hand, you can tell by the angle. That's an 8-degree angle, pin 2. Alright, now goes for that universal program I was talking about. Take a look at another one here. Looks pretty good, not too bad. Let's take a look at these pin 1s. Not too shabby. This one had a hole in it. That's why I got that Miller-Matic over there. Fix these holes when they happen. It happens, you know. Nothing's perfect. There's no such thing as perfection. That's a little bit warbly, but you know what? It's a penetrating weld, and you can tell. I don't know if you can see down in there. You see the discoloration on the pin there, and some of the black around there. That means that the weld is penetrating and there aren't any holes. It's a little bit warbly on the side there. I'm pretty sure that I fixed that when I switched over to pin 2s. But like I said, it's still a functioning weld. Just not the most pretty one. Alright, I got set up here. Got 100 pieces of tube steel stacked right here. First cycle. It's okay. Could use a little bit of work. It is a universal pin program, and there is going to be variance. But we're going to try to dial this in a little bit better for pin 1, and see what we get. So I'm going to go ahead and do that real quick. Throw her in teach mode. Unfortunately, I got to use both of my hands for this, but we'll be right back. Who has spit on my spots? Alright, that's more like it. I fixed up this guy. I moved this point up a little bit. I kind of moved this point over a little bit too, and adjusted an angle on this guy right here on the left. Unfortunately, we did get a gnarly one. Let's go check it out. Alright. I'm gonna fix up this hole. I might even actually get that on camera. Hell yeah, sounds like a plan, Stan. Gotta get me gloves on. Man, I could really use some new welding gloves. Alright. Somebody's fucking with my helmet. There we go. And if it's anything. This whole steel with the bodge. What's up with my welding helmet here? I can't see. And my helmet's screwing up. All right. This cycle came out pretty much perfect. I think what I'm going to do now is I'm going to get a recording of it, and if I get another bad one, I'll shoot another video of me fixing it. There was something up with my helmet. It looked like somebody adjusted the sensitivity settings, and I stood there for like 5 minutes trying to fix it up. I'm very particular about my welding helmet. These are my pens. All right, and we're almost about a quarter of a way through the order already. So, hell yeah. Okay, kiddos. Time to go for the gold. See, now that's what I'm talking about. Fast and efficient, and more fun than cleaning up Rain's duty. All right, let's try this again. I got one more hole. The weld is actually really good other than that. So what we're gonna do, this fucker. Oh, I guess I gotta turn the video off. Shit. Alright, that's a little bit better. Hopefully this time it's not gonna turn into a shit show. I should have this guy set. Alright. Okay, that's good enough. I don't know what's going on with this freaking helmet. I'll show you that. Alright, that's pretty much all I did. Just a little spot weld there. If I can get this son of a bitch fucking helmet to shade correctly. Typically what you want to do if the weld is looking warbly, it's kind of like when you're doing a reflow on a solder job. You're going to want to do a semicircle here and then a semicircle here, starting at the top. These are my settings on the Miller-Matic. I think I'm using 4 or 5 wire. But yeah, nothing much to it. Pretty easy. If I get a really gnarly looking one, I'll demonstrate a welding reflow kind of a job. Anyway. Alright kiddos, we're done with the first order, 200. Got a couple of bad ones here. I'm gonna fix these on camera and try to demonstrate a little bit of what I was talking about before. It's got a little tiny hole in it. Can't have any holes at all though. Probably just weren't seated right, probably my fault. This welding helmet is having so many issues today. Okay, just a little bit more of the same. Just tack welding those holes. I think maybe the battery in this thing needs to be changed. I mean, you saw me messing around with the helmet. I usually don't have trouble like that. So anyway, we're gonna move on to the next order. Okie dokie, artichokes. Well, we just finished that order. Finished up the right sides. Man, the welds look freaking good. Fantastic. At 200, I got 4 bad welds. This is not a programming issue. It's probably just a seating issue. We're gonna fix those up. So 4 welds out of 200, that's like, what, a 1% failure rate? It's fantastic. We got 100 left over here. I'm actually going to show you guys how my paperwork is done. It's a little bit archaic, but it gets the job done. So this is the part that I'm making, 15 inch arm with a pin 1. The CS right there stands for cart start. So I started off with a cart that had 500 pieces of arm steel on both sides, so times 2. The N stands for need. That's what I need for the order. So I needed 200 times 2, so 200 of each. Left hand and a right hand. So we just finished that. I always put done on my paperwork. And the reason why I do this, you want to come over here and see. So even though I designed the programs and do all the engineering and all the architectural work for for this. An operator is not going to necessarily have that same level of skill. So I have to make everything essentially stupid proof so that anybody, regardless, hey, what's going on, Dad? Hang on. All right, sorry about that. But yeah, essentially, you want to make everything as straightforward and as simple as possible, so that regardless of experience, even just somebody who's never done this before can come over here and just be able to, you know, hit this button right here and weld. I mean, that's kind of the point. The point of robotic welding is not just to be fast and efficient, but to be easy, to basically make the labor a bit cheaper, because, you know, a standard hand welder, I mean, even if they're not certified, you know, they can make as much as 28 bucks an hour. So anyway, we're gonna fix these up real quick. I'm gonna hopefully third time's the charm and this guy doesn't give me any trouble, and I'll show you guys a little bit more of how I trace back over these welds to make sure that they're good. All right. Okay, so this is what I was trying to demonstrate earlier. I still have a freaking problem with this helmet. I don't know what's going on with it, but see the little semicircle trace there? So before they had little holes at the bottom, and I patched those up. But if you have some spotty arc welds going around, it's a good idea to trace back over it. And you can look in there and you can see that sort of gray discoloration on the pin and on the inside there demonstrates a penetrating functional weld, and it looks pretty good. All right, so that's going to do it for this order. We're almost done. I'm almost done for the day. I'm going to do another 100 of these straight. I have another order. Actually, let's go ahead and notate it. Do 15-inch pin 1. And remember, we got to write down our need. So we need 1,050 in our CS. So remember, we did 400 here. So that means that our new CS is going to be 600. Remember, we started off with 500 on both sides, and then we welded 400. All right. So, but I'm just going to do 100 here and just call it a day. Mostly because I do not have 100 or 1,050 pin ones. That's all the pins I got. And I can go through this in probably about an hour if I'm just straight welding and not stopping to do, you know, like shoot videos like I've been doing. So anyway, I think that's going to be maybe my last video I'm going to shoot for this. I don't know. I might try out this chicken sandwich just for shits and giggles. I brought with me. I bought it yesterday. But all right. I'll see you guys in the next welding video or music or guitar thing or let's play, whatever it is I do next. All right, catch you later.